Hey, hello, welcome to the show. It's me, JP, and this is JP's product pick of the week. We're here, we're all together, we're back. The band is back together. Thank you for stopping by. Thanks for jumping over into our chats. We've got the YouTube chat open over here. Hello, Dave Odessa. Hello, Paragraph Avdelhagen. Howdy, Dave Odessa. Beep beep, honk honk, toot toot. Because of the taxi cab, yeah? Hello over in our Discord chat. So yeah, if you're over on Facebook or somewhere and you're wondering where the chat is, go check out our Discord. That's where it's happening. You've got one URL to remember, and that's adafru.it/Discord. Go there and then look for this right here, the live broadcast chat channel. We have a whole bunch of channels with a whole bunch of stuff going on, but that's where it's happening during the show there. Hello to Starman. Hey, Thin Man. Blitz City DIY, hello. Hey, C. Grover, Sam, Jay, Ohio, howdy. Thank you all for popping by. By the way, I just wanted to mention that this super cool Lego taxi is real. That's not generated by a large language model or whatever. No, that's an actual Lego taxi cab in the Fifth Avenue store in New York. I was there, and one of my daughters got a cool picture of me in the cab there. Not the background, that's fake, but yeah, that's a real Lego taxi cab. It does not drive by intention. You could probably roll it down a hill or scuff it down a hill, but no, it's more of a photo op than a functional vehicle. I think there are some functional full-size Lego vehicles built on chassis of actual cars, right? But not that one. That one's just a bench. So, yeah, let's see what's going on here. This is the Product Pick Show. I've got a product pick for you to go check out at that URL or that QR code. And if you go there, you will see we've got a very cool product pick that has been halved in price. We leave the product intact, but the price we have, thank you to the new product team, Travis, Jelly, and everyone at Adafruit for making all of these things happen, and for stashing away 100 of them before the show. So we definitely have some in stock, as well as maybe more than that. I'm not sure how many we had going into this, but it is a worthwhile product to go check out. I'm not going to spoil it just yet, although there have been hints, but go there, go check it out. And what I'd like to do next, actually, as is customary on this show, I'm going to play the new videos. And that's plural because this one had a couple, I edited them together. There's a little bit of redundant information, but there's also some good, neat stuff in the two new segments that Lamore did, followed by a update because this got a little product revision. Enough tease. Let's check it out. Buckle up. Take it away, Lady Ada. Where is the Lady Ada? That's not it. Here it is.
This is the Feather M4 can. So what is this? You love the Feather M4. It is your favorite microcontroller board. Mine too. 7051. How can you not love the Cortex M4 running at 120 megahertz? All these cool peripherals, DACs, ADCs, SPI, I2C, tons of PWMs, all the good stuff you need to run CircuitPython or Arduino super fast. Love this chip. But could we make it better? Yes. The SAM E51 is a variant of the SAM D51, and the E stands for CAN. Actually doesn't. E stands for Ethernet, but it also has CAN support. So it has a built-in hardware CAN peripheral, which means that all you need to do is add a CAN transceiver, which kind of handles like the voltage stuff on the end, and now you can connect it to CAN bus, and it's like a pretty good price. This thing's going to be like $25. And it works wonderfully with CAN on either Arduino or CircuitPython. We have code for both. We also gave it a bit of a scrubbing. We improved the power supply a little bit. We made the LEDs use less power. We improved like the NeoPixels so it doesn't. It's not on by default. You can turn it off for lower power usage. It's got USB-C instead of micro B, so it's kind of like a little bit spruced up. It still has what's nice about the SAM E51 is that it's like basically pin compatible, right? The only difference is that there's these 2 pins that can do CAN, and those pins weren't routed on the original Feather because I kind of knew eventually I would make this board. So, if you have any existing projects that use the Feather M4, it's basically like a drop-in replacement because pin A4 is the same pin A4, and like the I2C is on the same exact pins. The only difference is now we have these extra CAN bus pins connected to the CAN bus transceiver. There's a onboard 120 ohm terminator. You can disable it by cutting a trace if you like, but by default it's on. We also include a little 5 volt switch cap converter to give you a 5 volt into the transceiver. It's not required by some CAN buses, but we wanted to make it compatible with as many specifications as possible. So you get a full 5 volt differential signal, even if you're running on a 3 volt battery. So this is a nice upgrade. I like how compact it is. You just get your Feather M4, and on the end, CAN bus, and then we'll have Arduino and CircuitPython code examples released, so you can integrate it, read data from your car or whatever, or connect to an existing CAN bus. A lot of people really like CAN, so I'm glad that we could make them happy. So coming soon, sign up, and we'll get these in the shop in the next week or so. But a lovely upgrade to the Feather M4 family for those who want to do automotive or robotics projects. The CAN Feather, yay! It's finally out. It's in the shop, so you can pick them up. Finally, we were previewing it last week. So the CAN M4 Feather is basically, we took the Feather M4, which is like one of our most popular boards and is also in stock, and we upgraded the chip from the SAM D51 to the SAM E51. The SAM E51 is basically functionally compatible. All the pins do exactly the same thing, has the same amount of memory, same speed, same all that good stuff, except there's a couple pins that can now be used for hardware CAN bus support. And they're coincidentally on the right. It's almost like I knew that this was eventually going to be made. And on the end there, you can see there's a transceiver and a terminal block connection with CAN bus high and low. Those are differential signals. There's a little mini boost converter that gives you a solid 5 volts because CAN bus really wants to have 5 volts for the signaling. It's a kind of an old protocol. And it has also a terminator that you can 260 ohm resistors as a terminator. You can cut those if you don't want to have a terminator. And you can also put the terminator to sleep. You have 2 CAN feathers, and you see the yellow and blue wires between them, and those are the only data communications between them. You connect CAN H to CAN H, CAN L to CAN L, and you can have like as many devices as you want. Like it's easily 100 on the same 2 pins. It's like I2C, except instead of like addressing like I2C does, you just sort of listen to messages that are designed for you, and you can set your own address. People always ask, how do I have multiple microcontrollers communicate with each other? And if you only have 2, you can do UART. And if you have more than 2, you can use I2C, but it gets a little flaky and difficult. CAN bus is like super solid, and also means you can communicate with other industrial robots and motors and sensors. We'll be able to do car-based CAN bus projects, and it's not. It's nice and fast. It can do, I think, up to 10 megabit per second CAN FD, so it's kind of like the next generation. So you'll be able to work with anything. We've got a library code in Arduino and CircuitPython. And because it's native, you don't have to worry about an SPI CAN converter. It all happens inside the chip itself. So very handy. It does all the buffering for you and all that good stuff. This is a revision. We have our CAN Feather back in stock. It is the SAMD51 based CAN board. Now comes with the terminal block pre-attached. Might be in green, might be in blue, might be in black, but even less soldering than ever. It's kind of plug and play, ready to go. So you get, a SAMD51 that has a CAN peripheral built in. We toss on a transceiver, terminal block, and you're ready to do CAN communication on a Cortex M4 in Arduino or CircuitPython.
Yes, that's right. That's the product pick of the week this week, right there. There's a whole bunch of stuff going on. What is it? Right there. That's the product pick of the week this week. It is the Feather M4 CAN Express with the @SAM E51. So this is a Feather. It's got a couple of differences over the usual M4 Feather. So it's a Cortex M4 Feather. However, this has the transceiver and the CAN terminal blocks pre-soldered there right on the end for you, so you can plug in high and low data lines. It's a sort of a differential pair of data, as well as a ground reference. This has USB-C on it, unlike the typical Feather M4, which has a USB micro B. Those are some nice additions. And of course it has all the usual Feather stuff, so it's a 120 megahertz processor. We've got, I think, 512K of flash. We have 192K of RAM. We have 2 megs of SPI flash, so you can store files on there if you're using CircuitPython. You can also use Arduino on here. We've got the battery, LiPo battery charging on there over the USB, built-in NeoPixel, a million, zillion, billion pins on there, lots of PWM, UART, all the other peripherals you can imagine, I2C, I2S, bunch of ADC, bunch of DAC. So a really capable Feather. But the real headline here is the fact that you can use it for controller area networks, which is, as Lady Ada mentioned, really popular in, let me bring up the board right here, or actually, you know what, let me bring that right there. So there you can see it really nicely. We have the terminal blocks on the end there for CAN, controller area network, which is used in automotive, aerospace, robotics, industrial control, some home automation, and then any DIY projects that you can come up with where you want a nice high-speed, very robust wired connection so that you can have loads of controllers and sensors all on one network talking amongst themselves. You can filter messages, send one message out to everyone out there, just broadcast it, and then the ones that have a matching address will grab it and do something with it. So really, really great, and excellent for long, long runs of cable. So you can see here, let me go to this view. You can see here I have I'm just sort of torn apart an old Cat5 cable, and I'm using 3 wires on it. You could use some of the twisted pairs for even more robust noise-free operation, I suppose, but I'm just using 3 wires connected from this right here. You can see on one Feather on the terminal block, 3 wires, and then the same 3 wires are running across this, I don't know, 15 feet of cable to another Feather CAN, M4 CAN right here in the back. They both have a potentiometer on them there that I'm reading for setting the NeoPixel color of the one on the other side. So let me set this up in a way that's easy to see. I'll put Lars back there. Okay, so you can see there's a Lars. The other camera actually is a little better for looking at the NeoPixels. And you can see here when I turn the knob on this Feather M4 CAN, I am changing the colors on the NeoPixel ring back here on the other Feather. So it is sending out that message really nice and fast. And then in the opposite direction, I can come over here and send messages back to the one on my desk. You can see that NeoPixel changing. I'll go all the way over to the left to red, up to blue in the middle, back through purple, and over to red on the right. So this is a nice simple example inside of Arduino that I'm running here. And we'll look at that code in a second, but before I do that, let's take a look at the product page for this. Let me put some things away here. So here you can see it is product 4759, and it is half price right now during the show, $12.48. We should have plenty in stock. You can get up to 10 of them, so if you have big plans for doing home automation, some sort of car project, some sort of who knows what, get a bunch of them. You won't regret it because that's a Feather M4 for only $12.48. Normally it's $22 for a Feather M4, $24 for the one with the CAN, the different chip and the CAN transceiver. And you can take a look. If you scroll down, we've got the Learn Guide right here. And this will show you all the pinouts. This is showing one where it's not a pre-soldered terminal block at the end, but those actually come soldered on, so you won't have to worry about assembly. And then the pinouts here will describe everything, all the pins, how you can use them. As Lamore mentioned, it's a drop-in replacement for a Feather M4. Just gives you the CAN as well as the USB-C, so it's sort of nice upgrade if you have a lot of Feather M4 projects going already. And then you can see here we have examples of setup in Arduino IDE as well as CircuitPython. Now, unlike some of our other CAN products, this does not use a separate transceiver chip and SPI. This is actually built onto that ATSAM E51. So that has the 2 pins broken out for the CAN peripheral built right into the chip. So it's simpler to set up and use. You've got examples here of CircuitPython CAN-IO library for use on CircuitPython. And I'll show you what I'm running right now. This is the, if you watch here, as I'm updating, oh, let's see, let me bring up that window so I can see it. Where'd you go, Arduino? There you are. Let me see if that'll update. There we go. So you can see here, I just had to give focus to the Arduino window. As I'm updating this knob, I'm sending and receiving packets. So you can see the value going up to 1023, down to almost 0 as I turn this knob. And I'm sending packets out. I'm also receiving packets from this other one. So if we change this, you'll see the packet that I'm receiving changing. That's just showing the hex number that's coming in that I'm using. So that is 2 of them running basically identical code, which you can see here. This is an example that comes with the CAN library, the Adafruit CAN library. And so you can see here it's as simple as importing the CAN SAM E5X. So it's specific to this board. It's different than what you would use if you're using the, what is it, MCP 2512 or 15. I'm also bringing in NeoPixel. I'm setting up the CAN object, setting up my NeoPixel object, defining the packet ID. I'm using a timestamp to be able to check against the time on these. Got a little NeoPixel set up. We start the CAN bus, in this case at 250 kilobits per second. You can adjust that depending on your needs. And then this example is not doing any error checking, but you can simply send it out fast enough in this case that you're going to get it. You can set up reliable, we have some examples using reliable, robust communication so you can see if the packets have been received. And then in this case, every 100 milliseconds we're sending out a packet. We begin the packet with the packet ID, and then we're writing the value of this potentiometer, and then a stop bit, send end packet, and then we also have parsing of that on the way in to extract the hex value that comes from the other side. And then we have some convenience code for some color stuff. But that is a real basic example. We have even simpler example, one that will just send, one that will just receive, and then you can also check out the CircuitPython code for that. Thin Man over in the chat asks a really interesting question. Can MIDI commands be passed through CAN communication? Wild. My mind is blown. I don't see why not, but I've never considered that. I don't know of any examples, but try it. I love the idea of sending MIDI over CAN. Why not? Another question that came up was about car hacking. So I haven't done any car hacking with reading CAN or writing CAN. However, I did find on just a simple search one example from Dave Shetlama over here on Hackster.io. That is, you can build this vehicle monitoring system, and this goes into some detail using a Feather M4 CAN Express to monitor the CAN bus, and then I believe this USB to CAN gizmo you see here is just so that you can do this on a PC rather than hooking up to your car. So that's simulating having the car involved, but I believe you'd be able to extend this out to reading messages coming from the car at least. And if you're not familiar, you can do some interesting stuff with CAN bus hacking, things like setting up cheat codes where you toggle a window button 3 times and it lowers all your windows. That kind of stuff can be hacked if you know what you're doing, but it's a little bit, it's not for the faint of heart. I don't want to brick my car, so I haven't done any of that. But yeah, I believe, at least from this one example that David shows, you can use the Feather M4 CAN for some car hacking. Let's see. What else have we got? Does that cover it? I think so. So let's get ready to wrap this up. Yeah, so as you can see, nice fast response there on Lars. I can grab this board so you can see them both. Excuse me, Lars. At the same time, on my down shooter, that one's going to be very bright, unfortunately, but woohoo! Here you can see, so traveling over 15 or 20 feet of wire, even though they're right next to each other, you can see it's very, very responsive. Thin Man asks, what's the longest length of cable? I do not know. This is an excellent question. Let's check real quick. Let me just see at least what the quick check on the internet says about that. CAN bus wire max length, and this can vary depending on terminators and resistor values. Looks like 40 meters, shortest maximum length. Yeah, so that would be before you start having to change your transmission speeds. You can vary the speeds to deal with different lengths. But yeah, could be 100 feet as a rough guideline, could be more, could be less. But I know you can go with long runs. You can do things like star topologies or one single bus because the data is going to head out and everyone's going to see it. So it is pretty robust, and that's one of the reasons that CAN bus was created in the 1980s, was to just reduce the amount of wiring inside of a modern vehicle that had lots of infotainment system, anti-lock braking, sensors, all these things heading to a central processing microcontroller. If every run is its own run, that's just tons and tons of wire. So being able to run little CAN transceivers around and run on a single length, essentially on two wires, makes that a lot easier. Sam, yeah, the question also about the ground line, that is actually optional. You can run this demo. Let me pull this one out of here for a second. You can run this demo with or without that center ground wire that you see there. That is totally optional. The high and low pair will do it on their own. And I have no good answer as to why you would choose to run that ground wire. I figured it was there, so I did it. But if anyone knows or wants to research that, let me know. One potential reason is if you have different power supplies with these running on battery, if you want to have a common ground among them, that may be useful. But I'm not sure about that. All right. Yeah, and DJ Devon 3 says, prior to 96, all car companies had their own proprietary systems. Let me bring up the Discord here. And they're now known collectively as OBD1. Oh, those were, yeah, OBD1. I'm assuming that's onboard diagnostics, and now OBD2 didn't make it to the EU until 2002, 2003. Interesting. All right. Well, I think that's going to do it. So if you're interested in doing some CAN exploration, answer some of these questions, go grab one or two or 10 and see what you can do with them. All right. I think that is going to wrap it up. So let's see if I can mount one right there. Yeah. Right, that right there is my product pick of the week this week. It is the Feather CAN M4. No, that's my product pick of the week this week. It is the Feather M4 CAN Express. Thanks everyone so much for stopping by. For Adafruit Industries, I'm John Park, and this has been JP's product pick of the week. If you want to go grab some, head over there. The price will go down after the show. Thank you everyone, and I will see you next time. Bye-bye.